Hey students, this is lesson 514. We're going to learn how to we're going to actually learn how to write equations to represent problems and how to simplify and solve them. Let's start here with this think and discuss. What do you recall about the angle relationships and figures like these? We're going to need these. If I take this, I think I'll enlarge this a little bit. One thing we learned is in something like this, let's say I label this 1, 2, 3, 4, 5, 6. I'm talking about the angle measures now, 7 and 8. And remember, these two lines mean that the lines are parallel. So if you have two parallel lines and they're cut by transversal, you get some angles that are the same. And they have different names, and the names aren't all that important, but like 1, 3, 5, and 7 are all the same angle measure. And so are 2, 4, 6, and 8. So there's really just two different sized angles. And then you have angle pairs like angle 1 and 2, those are supplementary. 3 and 4 are supplementary. 5 and 6 are supplementary, and 7 and 8 are supplementary because they make straight lines. And there's some other ones too that are supplementary, but just kind of keep that in mind as we go through this. And one thing we know about a triangle like this, I'll label that angle A and angle B. This means that that's a 90-degree angle. Well, if you add up all three angles of the triangle, A plus B plus 90, that has to equal 180 degrees. And that's always true. Okay. So let's just look at some things here. Remember that there's a lot of different phrases that can all give the same result. Like these two, both of these, if we simplify them, we get 28. And if we replace the 7 with an h, we get 35 minus h, 4h. Now, those will only be true for a certain value of h, which is 7. All right? So let's do the first problem here. It says Jamie drew a triangle with angle measures 50, 25, and 105. So that's an obtuse triangle, so it might look something like this. And the biggest angle is 105. And then the other two angles are 25 and 50. Okay. It says let the variable d represent the 25-degree angle measure. So instead of 25, we're just going to put d there. But remember, we know that that's a 25-degree angle. And write expressions in terms of d to represent each of the other angles. So there's a couple ways we could write 50. We know that 50 is 25 more than 25. So we could write for 50 d plus 25. Or we don't double that 25. So we could write 2d for that one. Okay? And in the 105 is just a couple of examples for the 105. You take the 25-degree angle and multiply it by 4, which would be 4 times d, that's 100, so you need 5 more than that. Or you could just think, oh, 105, that's 80 more than 25, so we could just do d plus 80. Just a couple of examples. So we want to write an equation showing the sum of the three angles is 180. Use the expressions in terms of d to write the equation. So let's pick a couple of these expressions. Let's use this one and this one for the other two angles. And then d is the 25-degree angle, so d plus 2d plus 4d plus 5. That has to equal 180. Now, to solve that, the first thing you're going to do is simplify it. So we've got some like terms we can combine. D plus 2d is 3d plus 4d is 7d plus 5 is equal to 180. And if you remember solving equations, you can either work backwards or you can subtract the same amount from both sides, basically do the same thing for both sides. If I do that, I get 7d equals 175. And if I divide both sides by 7, I get 25. Did we get d equals 25? Yes, we did. And that's because we created those equations out of the number 25 to represent that. All right. Number 4. This is a circle, and one thing we have to remember about a circle, we're talking about two angles, a bigger, that angle and that angle. And if we add up those two angles, we get the distance all the way around the circle, which is 360 degrees. So I'm going to write an equation to represent that. I know that if I add these two angles, I will get 360. And now I'm going to simplify. I got some like terms. 8x plus 0 is equal to 360, and then I can just divide both sides by 8, and I get x equals 360 divided by 8, which is 45. Now that I know x is 45, I can find the measure of the angles by just substituting the value of 45 for x. So one of the angles is 4 times 45 minus 35. The other is 4 times 45 plus 35. And those measures are 145 and 250. And to check that, you just want to make sure that those two add up to 360. And I can date it. Okay. For number 5, it said Matt drew a parallelogram that was not rectangular. He labeled the acute angles A and the obtuse angles B. He measured the angles and found that the measure of A was twice the measure, and measure of B was twice the measure of A. So he drew a parallelogram. So that would look like this. So let's say this is Matt's parallelogram. And says that he noticed something about the angles. First, he just labeled, he knew that that angle and that angle are the same in a parallelogram, and those are the same. And then he noticed something about it. He noticed that the measure of B was twice the measure of A. So, what we can do is we can say that B is equal to 2A to represent that information. And so the expression 2A is the same as the expression B. All right? And now we can replace B with 2A because we know those angles are both twice as big. So we'll just put 2A there and 2A there. And then we're gonna find the measure of the angles. We know that a parallelogram has parallel lines, and there's a line that cuts across those parallel lines. So if you remember from the lesson a while back, that these two angles, A and 2A, will be supplementary. In other words, they're going to add up to 180. So 2A plus A is equal to 180. You could also remember that in any quadrilateral, all the angles will add up to 360. So you could write an equation that way also. And that equation would just be A plus 2A is 3A, plus A is 4A, plus 2A is 6A equals 360. You can do that one. You'll get the same thing. A plus 2A is 3A. Divide both sides by 3, and you get A equals 60. And if A is 60, that's the smaller angle. The other angle is twice that, 2 times A, so that other angle is 120. And that was angle B. All right. Let's just do a couple more problems here. Create an exercise for another triangle or quadrilateral similar to exercise 3. Draw a sketch of the figure. Label the angles with the expressions you created. Trade figures with your neighbor. Write the equation and solve. Fine. You guys can do that in class tomorrow. Let's look at number 6 here and do a couple of these problems. And then we'll do the rest in class. I think you'll get the hang of it. So we want to write an equation to show that some of the angles in each of these figures. Now, so we have two parallel lines cut by transversal. Remember that there are some angles that are the same, and there's angles that are supplementary here. And these two angles, this 60-degree angle and this angle x, are not the same, but they are supplementary. So we're going to write x plus 60 is equal to 180. And to solve that, you just need to subtract 60 from both sides. I'll let you finish that up in class. Or you can just pause here and do that. And the next one, we have a triangle. And I think this W is supposed to be inside there, right there. So in a triangle, if we add the three angles up, we're going to get 180 degrees. So W plus 65 plus 90 equals 180 degrees. Simplify that, you got like terms there. So you get W plus 155 equals 180. Just subtract 155 from both sides to get the answer. This is a parallelogram, and we can tell that because we have two sets of parallel lines as indicated by the little red marks there. That means that those opposite sides are parallel. So, and since we have parallel lines cut by a transversal, we know that we have supplementary angles. So K plus 60 equals 180. And we can solve that one, just like we did the first one. All right, I think we have time for one more here. It says write an equation to show the sum of the angles for this triangle. Actually, I think you can handle that one. Let's try number 9. 9's got a little bit trickier there, so maybe we'll do that one. It says write an equation to show the sum of the angles for this quadrilateral. Solve the equation to find the value of x. In a quadrilateral, all the angles add up to 360 degrees, but we don't really know anything about that. Some of you might say that that's 90, but we don't know that unless it's marked 90. But one thing we do know is right here. We have two angles that make a straight line. So that means 4x plus 6x is equal to 180. And 4x plus 6x, that simplifies to 10x. And so 10 times some number equals 180. Well, that number is 180 divided by 10, which is 18. Now that we know that x is 18, we can substitute that in for x in each of these three expressions and get the values. Let's do this one first, 4 times x. So we're going to substitute 18 in for the x and do 4 times 18, which is 72. 6x plus 3, we need to do 6 times 18 plus 3, which is, let's see, that'd be 108 plus 3 is 111. And the other expression, 2.5x plus 50 is equal to 2.5 times 18 plus 50, and that's equal to 95. So we got 3 of the angles right there. 72 is the bottom right. So 72 is that one. The one up here, 6x plus 3, that's 111. And 95 is this one. Those kind of seem mixed up. They don't look like they're that size, but we got to go with it because now we can just label this one A and figure that one out. All of 4 of these angles will add up to 360. And I'm going to let you finish that up either now or in class tomorrow. And that's where we're going to stop off this video. All right, I'll see you tomorrow.